This lecture we will learn about competitive inhibition of enzymology. A substance which competes with the substrate for binding to the active site of an enzyme is known to be a competitive inhibitor. These inhibitors usually resemble the substrate structurally in binding with the active site but lack the resemblance in functionality and cannot form products. One of the examples for this is malonate, which is a competitive inhibitor for succinate, a citric acid cycle intermediate which forms fumarate. Malonate structurally resembles succinate but cannot be dehydrogenated, so fails in forming products. Now let us see the kinetics of the competitive inhibition. When an enzyme is bound with the substrate, it forms enzyme substrate complex and further forms product and enzyme is released out. And an inhibitor, when it binds with the enzyme, it forms an enzyme inhibitor complex and it doesn't form any products. Assuming that the inhibitor binds to the enzyme reversibly, then K1 is equal to concentration of enzyme into concentration of inhibitor whole divided by concentration of enzyme inhibitor complex. If we take total enzyme is equal to concentration of enzyme plus concentration of enzyme inhibitor complex plus concentration of enzyme substrate complex, as both inhibitor and substrate compete with each other in binding with the enzyme. In accordance to the steady state conditions, concentration of enzyme is equal to Km into concentration of Es by concentration of S. Substituting this equation 3 in equation 1, we get this concentration of enzyme in equation 1. We get concentration of enzyme inhibitor complex is equal to concentration of enzyme into concentration of inhibitor whole divided by K1. If we just rewrite this, then if we substitute, then we'll get Km into concentration of Es into concentration of I whole divided by concentration of substrate into K1. In this step, we are just replacing this concentration of E with this expression Km into Es by S. Substituting these things in equation 2, the total enzyme here, concentration of enzyme plus concentration of enzyme inhibitor complex plus concentration of enzyme substrate complex. If we take common among all of these, we can take concentration of enzyme substrate complex as common and we can get Km by Es as the another common factor. Km by Es here, Km by Es here. Then we'll take 1 plus 1 here represents enzyme plus concentration of I by K1. This expression represents the concentration of enzyme inhibitor complex plus 1 Es. 1 into Es, this expression concentration of Es. Then concentration of Es is equal to, if we replace, if we take Es here and concentration of total enzyme here, we get concentration of Es complex is equal to concentration of total enzyme into concentration of S whole divided by Km into 1 plus concentration of I by K1 plus concentration of S. If we take initial velocity as the partial derivative of products divided by the change in time dt, then we can take K2 into concentration of Es. K2 is the reaction constant in the formation of products from enzyme substrate complex, is equal to K2 into total enzyme into concentration of substrate whole divided by Km plus concentration of S. The initial velocity is expressed as V0 is equal to K2 into Es. If we expand it, then we get K2 into Et, total enzyme into concentration of substrate whole divided by Km into 1 plus concentration of inhibitor by K1 plus concentration of substrate. If we take whole of this expression as the alpha, then we can rewrite it as Vmax is equal to K2 into total enzyme concentration, as in the equation Vmax is equal to K2 into concentration of total enzyme. V0, the initial velocity V0 is equal to Vmax into concentration of S whole divided by alpha Km plus concentration of substrate. If we have to write the reciprocal of this for the Lineweaver-Burke plot, then 1 by V0 is equal to alpha Km by Vmax into 1 by substrate concentration plus 1 by Vmax. This represents the double reciprocal form of the competitive inhibitor. As discussed previously, this graph represents the competitive inhibitor Lineweaver-Burke plot when plotted against 1 by V0 with 1 by substrate concentration. Here the Km increases for the substrate concentration and Vmax is same for both inhibitor and the substrate. Thank you.